It was really cool that Red's Rhetoric came in here today.
I like Blue's Rhetoric way better.
I mean, Red's pretty popular. If Geo's getting people like Red's Rhetoric, this server name's getting pretty popular.
Eh. It's not about that. It's just other Globe servers suck.
Right?
Did you hear that earlier, Beast? They were talking about Cel-Theo and Alan and Shane, and because Astronomy Live and Red's Rhetoric came in, and it all got brought
missed
up.
it. I was working. Like I said, I just got off.
Reds was saying that that he wants to possibly finance to hire a pilot to do a flight, and then do like the Cel-Theo version that Astronomy Live, originally in that first debate they did where he brought that data, and Reds was saying that like he might even hire a pilot to replicate it, and then he wanted like Amphibious was kind of going back and forth with him, and he's like, will you actually sign in ink that like if we do this and it debunks the Cel-Theo? It got a little heated at some point. Yeah.
You cut your jugular and sign it in blood that you'll revert to Globe Earther if I show this to you.
I got you $200 to come to Florida with me and watch these balloons. Like, no. The fuck, dude? Dude, it was crazy. Let me talk about anything but the actual method itself.
Yeah, that's my contention. I called him out on it, on like how he brought that evidence forward and expected
totally hidden it. Like if this was discovery, they didn't give any discovery. Right?
But
Alan's been publishing every single thing online for anyone to grab. This guy just comes in and just like, why don't you explain this? It's like, all right, you never presented this data beforehand, so I guess I'm just gonna have to look at it. And then get
so
back to you.
his response was, well, in the second Cel-Theo debate, which I haven't seen for some reason. I don't know why I haven't seen that. Apparently Alan, and Shane had time to go over it, and they were basically just like, well, you can't replicate the exact elevation of the aircraft.
Dude, and then he said something stupid like, you don't need reproducibility for science. Like, what the fuck? Shut the fuck. What are you talking about?
Yeah, it was wild. But that was in the first one, wasn't
it? I can't remember. I don't know if it was the first or second, but either way, like you're going to use something that's totally not analogous. You're using airplane heights, which is already linked to the geo or to the ellipsoid, the WGS-40. So you're getting like, you're not comparing it to the actual ground, like what the ground's actually doing. Known mountain heights, there's a reason why we use that, because then we can both say like tangibly that height's not going to change unless you think the fucking ground is sinking or whatever, or rising.
Yeah. So that's exactly it, man. So he was just trying to get me to be like, if all my needs were met, right? All the specifications, the parameters that I think, if they did that, would that change my mind about the original Cel-Theo? And I was like, well, it would just contradict what the mountain occlusion showed, first off. So that would be weird that it just directly contradicted. And so I was just like, I don't know exactly what you'd want me to say. I was just like, but first I would have to research the parameters because I'm not the sharpest on it. And I would have to like get what I was like, there has to be a reason. And you just said it, how the aircraft are tied to the
WGS-40 or 84.
Yeah.
Sorry, I'm a little big.
So it's not even analogous to the Cel-Theo method.
No.
Yeah, I wish I would have known that info. I would have just pressed him on that. But yeah, I pressed Astrology Live on his underhanded tactics. And then
I remember back in, I think it's 2016 when Flat Earth is really just kicking off good. Red's Rhetoric and Jaron had a debate on non sequitur, and it was a big debate. Like a whole bunch of people watched it. And back then on non sequitur, if you subscribed during the show, it would pop the name up at the bottom of the screen. And my son subscribed during that show, and it popped his name up at the bottom of the screen, his internet name. And somewhere you probably look it up and find it. I remember watching it way back then. They were all just getting started.
Yeah. I guess so. But was that you, Amphibious, that was saying like, "Oh, I wish I would have known that earlier"? Is that you that was talking?
Yeah, because I would have just been like, well, it's not even the same, because they kept saying it is the same methodology, just using
No.
aircraft, and yeah, it's not.
Yeah, mountains and aircraft are totally the same thing. Crazy, dude. How could I repeat what they found? Oh, I can't ever, literally. Okay.
Oh, so yeah, Red's Rhetoric was like, I will pay a pilot to do multiple days, same flight path, so that you can confirm
Why don't they actually just
that it's
fucking do the method? Why do they never,
Yeah,
ever, ever actually want to talk about the actual method? Or like what's actually on the spreadsheet? Oh, I know
because they
why. Because
just
it destroys the globe. Because it shows the globe only exists apparently through celestial refraction, and that the drop over distance that's expected isn't even there, dude.
yeah, and then they just go with their the Jesse Path of Light explanation.
Well, what about the appearance stars that no one ever actually talks about on the Ether Boy side, because that's not what we care about. We actually care about the true position. But I'm going to talk about the apparent position every single time.
Crazy, dude. Sorry.
No, that was perfect.
Dude, after a year of non-arguments, it just gets sour, which is why Alan's just like, you know what, fuck it, I'm just gonna make it about the null hypothesis, because there's so many other cool things to talk about. No one's actually rebutting this shit. You know.
I don't really think my argument has been properly rebutted. My argument
Lay it out.
is called, it's the Terminator zigzag line. If it's possible for refraction to go 273 miles and even further, carrying light over the curve, then you would have sunset and sunrise times that varied based on the amount of refraction. So because we don't have this kind of zigzag Terminator line, we don't have that kind of refraction that is required to make the Earth a globe again.
Oh, no. They actually do invoke it. Like, for example, the Novaya, I can't pronounce it. The Novaya Zemlya, I think that's how you pronounce it. The Novaya Zemlya effect, right? Which basically shows like the sun layering in like kind of like a Krabby Patty, like a SpongeBob Krabby Patty kind of looking thing. And it's supposed to be below the horizon like 10 minutes ago, 13 minutes ago. It'll be lingering on the horizon. And because you have like this layering effect, you have like three different types of refraction going on. They have to basically invoke like a what is called a thermocline, which is basically like a version of tropospheric induction, but it's just like a sharp change in temperature that's all the way over the horizon, which is allowing it to be projected over the horizon for as long as it was. It's insane.
So are you saying that argument is a rebuttal to my argument? And that's what they would say.
Yeah. They would just be like, yeah, that's to be expected. At that low of an angle, when you have the sun at the horizon, you're supposed to be seeing refractive effects like that. That's how you know we're on a globe.
All right, so can you show me the Terminator zigzag line then? I guess would be my question.
I don't really know what the Terminator zigzag line is, but
It would be something that would have to exist if refracted light can bend around the curve for hundreds of miles, like when we see these mountain ranges from really far away. So if that's true, then there would be enough refraction one day, and then one day there wouldn't be, or in one place there would be, and in another place there wouldn't be. For example, If this sort of thing is happening, where refractive index is really high, and then other places it's really low, then there would be
That's the
days where it
thermocline.
would. Sorry.
Oh yeah, so that would be, I guess that is the Terminator zigzag line.
Right. So what I'm saying is there would be days to where it would be dark in Dallas, Texas, but in Waco it would still be light time because of the refractive index, even though the Terminator line should have already passed them, but due to high refraction, it didn't. So where does this happen? Because it's all about, the observations fitting their model. So they're claiming these observations happen. Where else can we see them except for when the Earth is supposed to be curved?
Yep. No. So when I said thermocline, that's literally like it's like a sharp change in temperature that makes like that zigzag that you're talking about, because what they claim is that certain rays from the sun get trapped in that thermocline, essentially reflecting it, like you said, all the way around. I'll show you a paper. I'll post it.
Hello.
You ever see the Novaya Zemlya effect?
Okay.
You ever seen it? It's freaking wild, man. It's probably one of the coolest
Hello.
things the sun ever does.
Yeah, you're welcome. Have a good one.
Oh, my bad.
Sorry, but I'm muted.
No, you're good. Check out this playlist though. This lady named Mila Zinkova, she like lives in somewhere in California, and she sees these all the time, So it's not just like a specific effect that happens in the Arctic, but like, dude, wild looking. Here we go. There it is. There you go. And I'll find the paper that explains some of it.
Beast, you forgot to mention one of my favorites. All the weeks they said, so where's the star once it passes the mountain? What's its position then? That was that was the best. Everyone thought that they had some slam dunk about negative star positions because it's going below your feet. It
Yeah,
must be.
that was
It's crazy, dude.
I know.
Yeah, you could just take the very first one, right? 231. You just do a flat baseline prediction, right? You get rise over run, gives you 231, right? And then for the globe, it's like 219 or 217, depending if you want to add in terrestrial refraction or not, right? That's just the drop over distance. That is the difference between flat and globe, right? The drop over distance. That drop over distance equates to 13 arc minutes, right? Half of the arc length, which means the star has to be dropping in the sky, right? In their model, the Earth is rotating away, causing the declination of the stars because it's 15.04 degrees per hour, right? So by the time you, the observer, the zenith of that star has to drop 27 arc minutes before it gets occluded by that mountain peak, right? So if the globe doesn't have it to where it's being occluded earlier, then that means it went the entire arc length, which means that if we were to add the entire arc length, like the 27 arc minutes from the true position of the star from where the observer is, and then you add that back in, basically you go to the mountain peak, so you're basically re-adding, you're flattening the curve in order to compare it to what the rise of run would be, and it matches, dude, every time. Like the significance of that is so insane, because that literally means the drop over distance is just an apparent phenomena, which means there is no actual substantial drop to make the globe work. that star drop that we're seeing, like it's literally just stars moving away out of your field of view. And like if there wasn't a mountain peak there to actually show that substantially, right? Then they would just literally hand wave dismiss it and be like, well, how much was it still over the horizon? Okay, then that's how much it needs to celestially refract. And they just ad hoc and dismiss it. But now since there's an actual physical mountain peak there, it's like you can't do that. You can't claim it's just refraction at that point. Because then
Could
if
you
you were to take sorry.
finish? And I had
I was gonna say, because then if you were to just take in the apparent position, right, like at the mountain peak, the apparent position is 245, which means it would be 15 degrees or 15 arc minutes above the mountain peak. But that's not true because you can't see the star anymore. You know what I mean? Like it's just the coolest thing ever. But what were you gonna ask?
Yeah, if you wouldn't mind, if you could clear up, there were a couple instances, or maybe more, I'm not sure, where the globe model occluded before the flat model. And I remember that being like a contentious thing they brought up. I just can't remember what the explanation was that. You know what
Yeah,
I'm
the
talking
true
about?
position of the star actually, yeah, where it was better time for them. But here's the problem:
Where they were just like,
you
well,
have
it
to.
shows that it just shows there's an error of some sort, or how ineffective this
Oh,
uh,
there's an error.
method is
No. The
because
error is on both
because
sides.
okay, yeah, because they had brought that up. They're like, well, look how ineffective this is because sometimes even the globe model occludes before the flat Earth, which should never happen, is what they said.
What? What?
Mhm.
Dude,
I
I
believe
I
what
don't
you're
know.
You
talking
don't
I don't
about
know.
remember?
is
Go ahead. What?
some of the observations that Jesse took. He cherry picked a location so that he was way too close, and that the altitude of the item obscuring it, like whether it was a mountain or whatever, was very low. So it just created like ambiguous results.
Well, okay. Here's the thing. He knew what he was doing because you can figure out the ratio beforehand. So what he did was he took a mountain peak, Blinn Mountain, and the location that he was in. Basically, the drop over distance equaled the exact same amount of celestial refraction needed. So basically, the drop over distance was predicted. And guess what? In that area, at that angle, with that star, the amount of celestial refraction that's calculated is the exact same amount that the drop over distance is predicted, right? So then the ratio, you can find that ratio anywhere with certain stars. You just need to match that, right? And then what essentially he's doing is saying that, well, if I can continually match the globe side in terms of like better timing by incorporating celestial refraction every time to that ratio, then all Jesse is showing is that the drop over distance is literally apparent. That means it's just an apparent phenomenon. Because if you didn't have the celestial refraction, right, then you wouldn't have been able to claim that it matches the quote unquote timing that we have. Because the timing is still the timing, right? Like no matter what, it's still matching in terms of like a rise over run. Like that's the significant part of it.
Well, and it's not dead yet. It's still infancy because there needs to be a
We
bunch of
need
southern
southern
observations. Southern,
observations,
yeah,
dude.
yeah. See,
I
I
need to
can't
see
wait.
that. Well,
I
no one's
know. I'm
doing
real
it.
interested.
Fucking
Yeah,
$200 is not
because it,
enough to. Oh, here's Rixky. Perfect time. This Aussie over here. We're still waiting on a southern measurement.
yeah, it'll start to help uh reason out why we see what we see down there,
Dude, if we
out
see
there,
something
whatever.
totally antithetical to the Cel-Theo method, I would actually be down for that. I want there to be something different. You know what I mean? Like I don't like let's just say that it's the exact same results that we get in the northern hemisphere. Then dude, it's flat, dude, everywhere. Like there's no actual Like that's insane if that's the case. And they literally just made the nautical almanac just taking flat baseline angles, like elevation angles, just normal elevation angles of stars, and then timing it, connecting it to like a spherical coordinate system because that's the best way to explain stars at infinite distance, right? If you had a flat sky, essentially, well, what's an infinite radius of a sphere? Like the infinite radius of a sphere is literally a flat baseline. So I mean, I don't know. I really like the Cel-Theo because it helped me understand a lot of their model, like a lot of it.
Yeah, I'm in the same boat. I'm also curious, like in the south, depending on how far out, like if you'll see a left to right differential. So you know that like if how the AE map is a problem because of the star trails in the south. But
Not a
what
problem.
if when you do well, yeah, no, I mean, I get it, but what the common argument is, what if you see that they don't, that the real position is different left to right as well?
Possible.
Yeah, like if you're actually facing east and west, not, not south, but you're in the south facing east or west to do an occlusion or an, what would it be
Emergence.
called? Emergence, yeah.
No, the
If the
emergence is
position left to right.
if you were to just treat it opposite, it's the same thing. It's just like you're looking to the west, like in the north, you're looking to the west for occlusions. So then in the south, when you're looking to the west, you're looking for emergences. It's just reversed.
Hmm.
Which doesn't really. I'm still trying to like. Globers are so comfortable with it. Like, well, that totally means you're on the globe. But like, dude, we have two different star fields. That makes no sense.
Yeah, it's almost like
Exists on a
it's a
globe.
bar magnet with two poles.
Could be multiple, man. Who knows?
You know what I mean? You ever see magnetic under a Ferris cell or whatever?
Yeah.
When you look at it on a spherical magnet, it doesn't. You can see the block domain wall in the center, but it doesn't really look
The only
as
problem is
much like
magnetic
what.
declination, and you only have one pole that you have a magnetic attraction to, which is so weird.
Yeah,
You
well,
have a
if you
monopole,
have
essentially.
if like in a flat scenario, if you had like a bar magnet where you have two strong poles that are equal in strength but opposing, then the field looks similar to like the star trails in the equator.
But there is no magnetic attraction in the south like that, though. That's what I'm saying. That's the weird part. You know what I mean? Like if you were
I
to
thought,
go on a magnetic declination map right now, they have like these old school ones. Let me see if I can find it. Right, you start clicking in the south anywhere. Some of the magnetic declination is like 140 degrees. Like
yeah, I was gonna
what?
say you have to turn around and what you're,
Like that's
yeah.
not it's not equal. You know what I mean? Like that's crazy.
Hmm.
I know, something to chew on for sure.
Yeah, I didn't think about it that way.
Hey, don't let us just nerd out. If you guys want to jump in, jump in. I'm playing Arc Raiders right now. I'm about to pop in. Larry, did you check out that Novaya Zemla sunset?
I glanced at it. It was a sunset. I didn't really understand how you kind of equivocated it to, or at least you steelmanned their argument against mine. Although I've never heard it before, that's somehow a zigzag terminator line.
you could say. I mean, I don't know about the zigzag Terminator line, but okay, so okay, here, let me post this one just so you can see what I'm talking about. Like, so apparently, the sunset time was 1844, so 6:44 p.m. She stopped filming at
Pardon me.
1856. So the sun was supposed to be set for 12 minutes. All right. Now, if you do 1 arc minute is 4 seconds real time. So 15 seconds or 15 arc minutes, so 15 times 4. So 60 seconds real time would be
That's right. I am a stoner. You're
yes
not
you
supposed to
are,
tell
Larry.
everybody at work that I'm a stoner. Oh, sorry.
Either way, that one's crazy. So the sun is supposed to be below the horizon 2.7 degrees. If you would equivocate that in real time, like 1 arc minute is 4 real seconds. 60 arc minutes in a in a degree. So 60 times 4, 240 seconds. So that's 5 8 or that's 480. So 480 real seconds plus 7. So like almost 6. Yeah, dude. 6 minutes of just lingering. It's pretty insane, dude.
What's the topic?
Novaya Zemlya effect. You would love this one, Ruhiv, because you're a refraction guy.
I am.
Check out the video I posted. Hey, globe or flat, you gotta admit that shit's cool looking. If you look in the description, it's interesting.
Does that happen in the South too?
It happens all over the place.
Like as equally as it does in the North, or?
I think there's more observations in the north just based off population and stuff. There's only a couple places in the south that see it all the time, but that's because they're stationed over there. But like, this was in San Diego, and then you can see it all along the coast of California. Then you can see it all along the coast of. Oh, hold on, I got some mail here.
It's a wild
Thanks,
sunset.
Daddy.
What? Novaya Zemlya, isn't that like an extreme refraction
Yeah, it's
event there?
supposed to be. Supposed to be, dude. This lady,
How,
Mila, she's recorded it like 26 times, dude. All
right, but how
across
is
all.
this meant to be Novaya Zemlya?
Well, that's the Novaya Zemlya effect. That is the
Is it?
effect in general, the term used for when the sun is supposed to be well below the horizon. I'm talking about like in the south,
That's what I'm
they
asking
invoke
for.
like, huh?
That's the part that I'm asking for. Like, I understand this is a massive Fata Morgana of everything,
Look at the
but
3
how is
different
the
layers too.
cool? But how is it Novaya Zemlya? Isn't that like a sunset? Sorry, a way after it's predicted, like an extreme refraction event.
Yeah, dude, 2 degrees, 70. It's supposed to be 2 degrees, 2.7 degrees below the horizon.
Right, that's the part I need justification on.
What? Oh, the sunset times for her area right there. It's like, it was, what does it say? 6:44 p.m. She was filming all the way until 6:56 p.m. I would say that's an
I don't
extreme
see that in the
event.
video.
So I think what we would have to do
Look at the
is
description.
repeat some of those long distance photos that are hundreds of miles away, and then when we see it, see if there's an extreme refraction of the sun during that time, because the sun would have to match the extreme refraction of the long distance shot if the Earth was a globe, right?
Where's the time of sunset and the time of the footage?
I'm about to send. Taking a screenshot. Sorry, I was in Arc Raiders. It's right. It's in the video description. It's right there.
Oh, hang on. I'm looking at the one at 30 minutes past.
Oh, there's another
Not
one.
43.
Yeah. The
Okay.
latest one. Latest one.
Right. Okay. 43 past.
That makes more sense. Yeah. There you go. I love how Ruhip, you just want to be the expert. So how do they consider this an extreme refraction event? I'll be the judge of that.
Oh, San Diego, surprising, yeah.
I know. That's why I posted it.
Judging what kind of
And sort
refraction
of-
for what?
that's
So
more likely
Demok,
the
so
polar
the
region.
sun's right there in the latest video I posted, right? The sun's supposed to be well below the horizon already in the globe model.
Okay. And what are you gonna get? Like, okay, you're talking to Ruhif right now. Is there any concession from him? Like, does he agree?
I just want to see. Yeah, I just want to see like what he thinks about it first.
Okay, yeah, that's what I was gonna. I would ask the same thing and see where we're at after he.
Are you checking it right now, Ruhif? Are you like seeing the location, her other resources? She's a
It
glober.
doesn't give the location. San Diego, is it, I assume? No, where is she? Sorry.
To give the elevation also.
San Francisco. There we go.
Where's it taken from?
Oh, dude, this is so cool. So she has another set of images where you can actually see the silhouette of what is that? It's a silhouette of something. She names it.
How do we know that this is refraction and not reflection?
Reflection of what? It's in front of the sun,
Clouds.
so it's blocking.
Oh, Taylor, I've
Well, there could
tweeted
be
you
clouds in
today.
front of it, and also at the same time, clouds reflecting the sunlight to the observer.
Yeah.
How high off the ground was she?
Well, interfering with the observer's reflection,
Or
regardless,
off
right?
from sea
Yeah.
level, I mean.
She's at the beach.
Okay, she's almost pretty much to sea level. Okay, and what's the... Ruhif, were you going to say something to me?
Yeah, I sent you a bunch of tweets about your surveying at Bonneville today.
You did?
I did.
Well, okay. Go ahead.
Just check your tweets. Check your notifications.
You posted tweets in relation to hers, you're saying? You responded to them, or?
Yeah, she posted her Bonneville Salt Flats theodolite measurements, and what's his name? Kenbo asked me to respond, so I did. And I'm just letting Taylor know that I responded.
Right.
The end.
I have a presentation tomorrow, but
Cool.
I would like to know what you said. I don't know if I can go interact with it much tonight.
I think you made an error when you. So you've got your left face for a right face. I think you've switched around the zenith angle. So like you had both left face and right face as 89 point something, but then your calculated zenith angle was 90 point something, like below.
You're gonna have to tell Jesse that.
Is this Jesse's
I'll let him know.
observation? I don't get it.
No,
Yeah,
he
but
helped me do the math. He like owned the spreadsheet where they had the calculations already in it. So that's some of my observations, and we're filling it in. But the actual like averages and stuff was from him, and because it's his he has like a bunch of spreadsheets already with formulas already in there, so it makes it much easier. I'll reach out to him, and can you circle in there what's incorrect?
Yeah, one sec. I think trial 3 was it? Yeah. So, oops.
What should the average have been?
Oh, God. There you go.
Yeah, but how is that? What do you mean should have been? If you looked out and Ruhef has a magical average for no matter when you look out, it's just a magic number, right? 50 nothing something. And then you look out and that doesn't pertain to what you're doing, then why would she take that and put it in the information, Ruhef? That would be skewing it up and lying, wouldn't it? Just to keep putting globe in there? I mean, there's something wrong with your idea of calculations or measurements. That all you can do is just calculate to a globe. And if they see that there's something different than the calculation that would be for an actual globe, it's like you have a problem, like, you can't understand that or something.
What if there was heavy cloud seeding with silver-like chemicals, and these particulates that are highly reflective are causing this event, and the clouds in front of the sun that are partially blocking it out are natural clouds? Like, how would we know which is which, right?
Right. And then, like, how do we even know, like, what? So, a picture of the sun, I mean, I get it. Something supposedly not supposed to be happening, but then you have Ruev saying, well, this is wrong. Yeah, it should happen every time. Yep, the average.
Oh, hang on. I might be wrong here, Taylor. Hold on.
Ruhif,
You
what
gotta
is
use
saying is
spectroscopy if to try and figure out the clouds are different.
what is the data you were saying is wrong, Ruhif, and now you're saying maybe you're not you're not correct that it was wrong. You're wrong that it was wrong.
So the face right. So when you flip the telescope over to sort of cancel out any possible collimation error in your thing, yeah, I thought both were above horizontal, but the other one is below horizontal. But now the problem is that your theodolite appears to be quite a lot out of collimation. Your error for the face left, face right shouldn't be any more than an arc minute. If it is, you need to collimate.
What was the error?
I haven't calculated it.
Oh.
Yeah, I'll do that at some point. I'll delete that tweet though. 1 sec.
Is it even more than
Delete my
arc
tweet
minute?
accusing you.
We're talking about arc seconds.
Yeah.
Hold on, Dan.
Delete that one. Delete. There you go.
You're rescinding your tweet debunk?
Rescinding one of them. One of them. Yeah, I'll do it properly again shortly. I'll double check it first and then, yeah, maybe. Fuck, what am I doing? Oh, sorry. San Francisco. Okay. Oops. All right. Uh, 2024.
Isn't that just going back for a second to the Novaya Zemlya effect? Isn't that problematic for the claim that the sun sets because it's going behind the geometric like curve of the ball? if sometimes it doesn't even do that at all.
When
Like
you say geometric,
it stays hanging above the horizon, as it were, for longer than it should. Well, there should be a physical ball there, right? Isn't that the idea with the globe
right?
Earth thing?
We're looking at it through an atmosphere.
Because over a planar surface, that's no problem at all for it to linger, because it's just there's nothing for it to obstruct. So if you have the conditions, you can just see it for longer. You would just have to say it's curving up around. But then how do you isolate that sometimes it curves up around, sometimes it doesn't? Like, just goes back to like
Measure.
even like the boats being obscured from the bottom up kind of thing. It goes the same with that. Since that happens in different positions and different days, you then have to invoke some kind of refraction effect. And then it's like, okay, well, how have you isolated if there is any curve there other than just the refractive effect in the first place? It's kind of rhetorical. I mean, it's a huge issue with the globe model, but
yeah,
unless you've come to
concentrating
something
on
new, there's no way that it has been isolated. But it's just a general question. I mean, if you want to respond to it, you can. But you'd have to be able to isolate that to know it's a globe, or to know that there's curve there, to isolate it separately from just the refractive effects in general.
Yes, correct. You can measure the gradient. That's how you isolate it.
Measure what? Temperature, or what are you talking about?
Gradient, temperature, pressure, humidity. Gradient. Or just get above the surface.
Oi, mate, don't you know it's a globe, Geo? You just measure the gradient.
What you guys been doing all these years? It's a globe, obviously.
Obviously, you just have to
The
get away
gradient.
from the actual observation and go higher, not on the beach. Nim, 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 nim.
Correct.
Oh, here's the paper, by the way.
Just check this weather balloon data.
Yeah, this is from 2003. The first recordings. Oh, dude, that's another thing that's so crazy that we were looking into in the Novaya Zemlya effect. Not only did it happen with the sun, but there was an observation of the Moon-Jupiter conjunction. And it's so crazy looking, dude. It literally looks like the moon. So the moon's supposed to be well below the horizon, and it's in conjunction with Jupiter. So like they're like locked together, right? Like at the specific astrological time, right? Yet you could see the moon and Jupiter, and the moon looks like it's like touching Jupiter, like it's fully above the horizon. Dude, it's so weird. Let me see if I can find it. Oh, it's so crazy. Let's see. Gotta grab this. Yeah, dude, this was fun. This was a fun little deep dive.
So you beeping?
Smoke alarm going off? Larry, get your life
What?
together. Here it is. All right. So, post a little screenshot. Wait till you see this, Geo. I just posted that PDF. And if you go to page like 7 or something like that, you can see the Jupiter Moon conjunction and what it looked like.
You reckon this is 2.7 degrees? I'm getting the center of the sun geometrically. One sec. Geometrically 1.88 approximately.
Yeah, I'm on it. Yeah, page 7. So wait, the Jupiter Moon conjunction also lingered?
Dude, look how long it did. It lingered.
The conjunction of the spheres.
So do you see how it says true bearing? Or I think it's A and B. Yeah, so A and B. So the elliptic conjunction occurred around A, right? 14 UT. Look what it looks like, dude.
Is that
So the alignment, it's supposed to be like literally in conjunct, like it's making like a vertical. So do you see like a little bit after B? That's what
yeah?
it's supposed to look like.
Whoa,
So
it's that
yeah,
distorted.
dude, yes.
Wow. Just in a matter of what, this like an hour and 45 minutes?
Hour and 45 minutes, dog. No, I don't think you can use refraction to explain an hour and 45 minutes of, lingering.
It's just claimed to be in 1597 too. The year 1597.
Yep,
Wow.
that's when the Novaya Zemlya effect came around.
And they
It's
have
just
this
one of the
accurate of
things.
like from that's a long time ago.
Now, if you look to the left of it, they're trying to recreate it with ray tracings. It looks so ridiculous, dog. But yeah, this is that temperature inversion. So, Larry, if you're looking at this paper, this is literally, I think this is what you're referring to colloquially or whatever, the zigzagging Terminator line. That's literally what that looks like in terms of like to explain the height versus the distance and versus what because this is over mountains on top of that geo. So that means they have to claim this. Look at this picture.
By the way, I just posted it. If anyone in chat wants to see
But
what
look,
we're talking about.
that's what they have to claim. So because it's over a higher mountain, they have to claim the light is going in the valley and then back up again. Like it's doing like a crazy woo.
Wow. Is that to account for it on a globe or just in general?
Yeah.
Before the globe, that's required.
Well, they have to account for. That's what they have to account for because it's behind mountains like that. Let me see if I remember correctly. Let's see here. So, let's see. It actually talks about it. Yeah, right there. So it says for all intermediate directions, the same inversion is found capable of conducting Jupiter's light and making it pass smoothly over the mountain ridge. So that little picture you see right there, that's over mountain ridge, like over a mountain ridge. So they have to claim that it's like going up and then down and then back up again over the mountain ridge. An hour and 45 minutes of it, by the way.
Wow. That is very dramatic. I basically moved it out of like entirely out of position. How many degrees is that?
I think it was something like if you look in the arc minutes right there, the transformation curve. So
A true bearing, it looks like at least like 2 or 3 degrees.
yeah, I think that's yeah, but the Jupiter Moon conjunction. So
Maybe not 3, closer to like 2 or maybe even 1.5
yeah,
or 2.
maybe even I think it's like 3. I think you're right. Let me see. Should say it in the paper.
So is that like an occlusion or an immersion?
I think it's an emergence. Because if you look at over time,
It's rising. Yeah.
correct.
I mean, that is just way out of position. Roof, have you ever seen anything like that? That's that out of position?
And it's where
I've been
he
listening
loves
more,
to
paying
look at
attention.
things, the mountain, right? Yeah, it's high enough.
I haven't been paying attention whatsoever.
I posted it at 5 minutes after. That's a Jupiter Moon conjunction. And look at 14 UTC time. It's obviously like Army time compared to like where that A is versus where the B is. Look at how much Jupiter is out of position with the moon, where it's in a conjunction. So once it gets to B and beyond, it shows the actual conjunction position. But before, it's like completely displaced to the left.
It's so crazy, Gio.
Does this happen elsewhere, like in modern day? Because this is from 1597. It's claimed.
They recreate it. If you look up above.
Photos.
Oh no, not up above, but they do. There are different references to it. Where they go back to the same area as well. Oh man, we did a whole deep dive on it, but I'd have to find the papers because we went deep onto these, all these papers.
Anyway, Novaya Zemlya, the 644 or 656, whatever it is.
That the sunset one, yeah.
Yeah. I'm not getting 2.7 degrees. I'm getting about 1.5.
All right.
That's without altitude either.
Yeah, it's still crazy.
Yeah, not that crazy.
Yeah, see, that's why the celestial theodolite's so important, Ruhif, because it actually shows that it can't possibly be refracted that much because you can't see it anymore.
What? Talking about a mountain?
Yeah, because
Yeah.
we're looking over a beach, right? We're looking at the sunset. You can easily hand wave dismiss it being below the horizon 1.5 degrees, which in real time is a lot. That's a long time above the horizon. And simply because of refraction. And how much refraction? Well, how much is it supposed to be below the horizon by? Okay, that much. Yeah, there you go.
Right. The time,
globe
the
saved.
extra time is not a problem. It's how much the angle is. Time's not relevant.
Time equals angle in your model. What are you talking about? Of course it's relevant.
Well, let's say you're at the higher latitudes and the sun sets, like an extremely shallow angle from right to left or left to right, whatever. All right, it'll if there's 1 degree of refraction extra, then it might take an hour of extra time to set.
I know you're
Whereas
comfortable
if
with
the equator,
that.
And the equator, it's set straight down. 1 degree might be a couple of minutes.
I understand that you're comfortable with that. That's
so the time. I'm explaining that the time is not relevant. The angle is relevant.
I mean, they're both relevant, to be fair.
I've just explained, if you go to a different latitude, the sun will be setting at a different diagonal angle. So the time is dependent on the latitude.
I know what you mean. Like,
it's not
depending on the latitude, depending on just how fast it should act. Yeah, I know what you're saying. But
right. Cool.
Regardless, it still should be below the horizon. You can invoke refraction like a magic spell. Refraction. And it magically saves the globe.
Or
it's fine.
You can get above the surface where you're not dicking around in this lower atmosphere.
Okay.
Which can be insane.
Let's go above the surface and look at the Jupiter Moon conjunction in January 25th, 1597.
Cool. So we're
and then we're looking at mountain ridges, so we're very high in altitude there. Now what?
So 25th of January. So I
posted the whole paper there for you.
Right, but they've made a prediction for when the moon should obscure Jupiter. And it did. So what's
No,
the?
so the conjunction is happening, right? But you're still able to see the moon fully above the horizon and Jupiter above the horizon, right? But
From where?
according to the where it's supposed to be true geometrically, right? Like in comparison to Earth, the moon is supposed to be aligned like it shows at B. So if you look at A and then look at B, right? B is what it's actually supposed to look like. You see what I'm saying? When it's above the horizon, nothing's obscuring it. That's what the conjunction is supposed to look like. The actual conjunction happened at A in terms of like when it was supposed to happen, but yet it wasn't supposed to be visible until B.
I just want to say I wasn't snoring. I was just hot micing on accident. So whoever sent me to a different room.
Oh, I didn't even notice.
Yeah, I just got sent to a different room. I guess somebody thought I was snoring.
All right, we'll mark it as no snore involved. Yeah. I just sometimes we just pop people down there instead of disrupting the convo.
It's fine. It ain't no big deal, brother. Don't bother me. But I will. Microphone. I thought I was muted, but I apologize. So y'all go ahead.
I thought it could have been a snore, but I wasn't sure.
I thought it was like a concert in the background, but nope, it was snoring.
Yeah, I think I was sitting here singing to myself or something, playing this game. But go ahead with the conversation there. I don't want to mess it up.
Something to chew on. Ruhif, let me know what you think. I'm gonna dip for a sec.